How about we just take a look at one of those polynomials on our calculator? So I actually typed in the first one, minus 2x to the fourth plus 2x squared. So went to y equals, typed them in, hit graph, and you can see we kind of have a W shape going down here. Notice that both ends are going down, and we expected that because it's a fourth degree and the leading coefficient is -2, so that means it's opening down. And if we go to the table, we will notice right here, -1, 0 is one of our zeros. 0, 0 is one of our zeros, and another one. 1, 0 is another zero. That is a way we can check to see if we found our zeros correctly. And we said they were at 0, 1, and -1. And if you look at the graph, it's at 0, 1, and -1. Okay, so let's talk about the multiplicity. Over here, x equal to 0 occurred twice. And that's because of that degree. That means it's going to occur twice. Over here, x minus 6 and x minus 6, that one occurred twice. So whenever you have a 0 that occurs an even number of times, then what happens is your graph touches the x-axis and kind of bounces off. It's not going to cross over the x-axis. So with this 0 of 0, when we look at the graph, notice what the graph is doing. It's bouncing right there at 0. It goes to it, it touches it, and then comes back. Let's see if I can just show. That's not what I wanted. Let me do this. There we go. So right here at the 0 of 0, the graph is bouncing. So anytime you have a 0 that has a multiplicity or it repeats an even number of times, it's going to touch the x-axis and bounce off. If a 0 occurs an odd number of times, your graph is going to cross the x-axis. The graph crosses the x-axis here at -1. You see it crosses right over it. The graph crosses here at the x-axis on the 0 of +1. So if the multiplicity is an odd number of times, it occurs once, 3 times, 5 times, the graph is going to cross the x-axis. If it occurs an even number of times, it's going to bounce. That is what this tells me. So we've got a 0 that repeats an even number of times. The graph touches the x-axis and turns around. If that 0 has an odd multiplicity, then the graph crosses the x-axis at that 0. And we actually already did this, so we're good. So here is our roundup of graphing polynomial functions. We want to first put it in descending powers, determine the end behavior, find the zeros and their multiplicities, find the y-intercept, and then let our calculator help us plot the curves. So let's start right here with this function. It's not in descending powers, so let's write it as an x to the fourth minus 2x squared plus 1. Now, let's determine the end behavior. And remember, that comes from this first term. And since the degree is even, the ends will behave like x squared. And since it's a positive in front, understood to be positive, they'll behave like a positive x squared. So I know that both ends are going to go up. All right, so both ends are going to go up. Let's work on the x-intercepts. Remember, we set our function equal to 0 and then use what we have in our tool bag to factor, find zeros. So let's set it equal 0. Whoops, I want the one that's in descending powers. So we're going to go with x to the 4th minus 2x squared plus 1. And it's in a kind of a trinomial format. There isn't anything common to all three terms, so I'm going to try this method of factoring. To get an x to the 4th, I could multiply x squared times x squared. To get a 1, I could multiply 1 times 1. And for those to add up to give me a negative 2, they would both need to be negative. So there's the factoring. Now let's set each factoring to 0. Well, you'll notice that x squared minus 1 is the same as the other factor, x squared minus 1. So I don't really need to solve both of them. So let me just take one, this first one. I'm going to take the 1 over, use the square root method, square root both sides, so I'd get x equal plus or minus 1. And over here, if I solve this one, I would get x equal plus or minus 1. Notice the degree was 4, so I'm looking for 4 zeros, and I have 1, 2, 3, 4. The positive 1 occurs twice, and the negative 1 occurs twice. So x equal 1 occurs twice, and the x equal negative 1 occurs twice. So based on the multiplicity, when it occurs an even number of times, the graph is going to touch the x-axis. So I've got a positive 1, I've got a negative 1. The graph is going to touch the x-axis. What else? We can find the y-intercept. I've got a little room here, I'll just write it. The y-intercept is found, remember, by letting x equal 0. So if I let x be equal to 0 in this problem, that means I'd have a 0 minus 2 times 0 plus 1. So it'd be 0 minus 0 plus 1, which would be 1. All right, so I've got my x-intercepts, I've got my y-intercepts. I'm now going to go to my calculator. So here is the graph of that function. Notice it's using these 3 points that we found by hand, and it's a W shape opening up. Both ends are going up. We knew that was going to happen. So let's just graph that function. Remember with the multiplicity? These two zeros had multiplicity of 2. They occurred twice. So my graph should touch the x-axis at those zeros, and it does. All right, so let's work on the next one. It's in descending powers. How will the ends behave? We're going to look at that leading term, and there is the leading term. That degree is odd, and the front number is positive, so that means on the left, it's going to go down, and on the right, it's going to go up. So the left is going to go down, the right's going to go up. Let's work on finding the zeros. So let's set that function equal 0. All right, so 2x cubed minus 6x squared. And let's factor. And I notice there's an x squared common to both of those terms. And there's a 2 that's common. So if I take out a 2x squared from a 2x cubed, I'm left with an x. And if I take out a 2x squared from a minus 6x squared, I'm left with negative 3. You can always check your work. Remultiply it out. 2x squared times x is 2x cubed. 2x squared times a negative 3 is 6x squared. It's factored, so let's set the first one to 0. Let's set the second one to 0. One answer is 3. And because of this square, I'm going to end up with x equal to 0, but it's going to occur twice. So I've got a 0 of 0. I've got a 0 of 3. The y-intercept is going to be 0, 0. Whenever your x-intercept is 0, 0, your y-intercept is going to be 0, 0. I know it goes down on the left, up on the right. At the 0, it's twice, so it's going to be bouncing. So let's go to the calculator and check it out. So here's what the graph looks like on our calculator. Notice the left side is going down, the right side is going up. That's what we said. It's bouncing on the 0, and it's crossing over here at the 3. So let's do our best to emulate that graph. Good enough. So we want to follow these guidelines when we're graphing polynomial functions. Okay, last one. Actually, you know, I'm looking at this one. How about we just go straight from the calculator? So take a second. Let's put that one in our calculator. So I typed it into y equal. I'm going to press graph, and there is the graph of my function. I need to know specifically where those x-intercepts or where those zeros are. So I am going to go to my table. And I see there's a 0 at 0. And I see there is a 0 at 1.5. Are those the only ones I need to worry about? Yep, the one at 0, the one at 1.5. Let's go ahead and graph that. So I've got a 0, I've got 1.5, and it comes down, makes a little turn, it bounces right there, so it comes down. Whoops, whoops, whoops. Okay, well, there we go. This is what I want. So it comes down, a little turn, does that, and then goes back down. And let me make sure I did that right. Actually, you know what I'm going to do? I'm just going to take this guy and just move him right there. Okay. Just checking him out. Oh, yeah. Good enough. All right, so we'll graph a polynomial function. We can find the zeros from our calculator. We are good there. The very last thing for this section, it's called the intermediate value theorem. Let me go to my calculator and show you what that means. Take a look at the table. Notice what happens between a 0. Notice that you see a sign change. Here is my x-intercept. I have a sign change. Notice over here, x-intercepts, I have sign changes. When your sign changes from positive to negative on the y value, then that means you have an x-intercept. That means you have crossed the x-axis. That's what the intermediate value theorem says. Now, let's use it. Okay, so let's complete the table of values for this function. I'm going to type it in my, I'm going to type it in my calculator. So here is the graph of that function. All right, here is our table of values. And let's just put those over here. I want to see what happens at 0, at -1, and at -2. So at 0, I'm at 1. At -1, I'm at 1. 0, I'm at 1. -1, I'm at 1. And I did not get a good look at -2. Was at -3. Since I see that between these two guys, I have a sign change in the y value. Whoops. When you see a sign change in the y values, and that means there is an x-intercept that occurs between those numbers. Because the y value has gone from positive to negative, that means it crossed over the x-axis. And if we look at that right here, you'll see right here at -1, I'm up here. At -2, I'm down there. The change in my y values from positive to negative, or negative to positive, however you look at it, that tells me I am guaranteed an x-intercept between those values. That's the intermediate value theorem, and that is section 3.2. As always, if you've got questions, let me know. I am happy to help.